Hello folks, let's talk today about tool breakage caused by misaligned holes. Now if you've got a plate or an assembly welded together or bolted together, whatever, or cast even, such as I've got illustrated up here, and you're drilling through fresh material, generally speaking it's not a problem. There can be a problem, we'll talk about that a little bit later, but generally speaking not a problem. But if it's got pre-drilled or whatever holes in here, holes that are pre-existing, and you have to open them up to a certain size, a larger diameter of course, and they're not perfectly aligned, that's going to cause you problems often. Not all the time, but often. So here we go. We've got a hole right here, and I hope you can see this on my little illustration, that this hole here is shifted over just a little bit to the right. What that means is that these two holes are not directly in line with each other. So when you take your drill, here's my drill bit again, and it's up in the spindle and it comes through this hole here, no problem, and everything is grand. But as soon as it hits this hole here, there's a lot of pressure here and no pressure over here. It's not cutting anything over here, but there is right here. So what does the drill want to do? It's going to go in the path of least resistance, and it wants to deflect over in this direction to line up with that hole. But it can't, because it's got this one up here holding it in one position. So consequently, there's a bit of a struggle going on, and a lot of times it's the drill that loses. Here's what's happening. It goes in there, it wants to push over here, and when the drill rotates around 180 degrees, now the opposite side is trying to push over there. So your drill is constantly doing one of these numbers as it goes through there, and it's flexing. Now that's going to be really tough on your drill, and if it's severe enough, it's going to cause it to break. Okay? But the other problem too that a lot of people don't think about is while this is doing this for anywhere from 1 revolution to whatever it takes to get all the way through, if it happens to survive it, even if it does survive, because this is going like this, what is it doing up here? Inside the spindle of your machine, it's busy wearing that out too. It's rubbing it back and forth, it's resisting it, and it's going to swedge that material one way or the other. It's not something that's noticeable, in generally speaking, and you're not going to be able to take the spindle and inspect it somehow and find that. But here's the thing, over the course of time, that's going to wear that spindle out inside there, at least a little bit. But there's more to it than that, like there always is. In machining, you've always got to dig a little bit deeper. It's almost like archaeology, I guess. Dig a little deeper. What's happening up here is not just in the spindle taper, but it's also in the bearings that support your quill or the rest of the machine there. That is also taking a beating. So as your drill is busy trying to find its way through 2 different holes that don't line up, it's wearing out your spindle taper here, your bearings inside there, perhaps even the casting on the machine. Now too, keep in mind that the drivetrain that pushes this drill through here, you've got gears, we'll probably talk about this a little bit later in another talk. The gears, the feed mechanism is also taking a hit. How so? Because when things line up a little bit, it's real easy, but when it doesn't, and the gears happen to be in one position, over here it's got to work a little bit harder. Then it's easy, then it's hard, then it's easy, hard, easy, hard, easy, hard. That's going to wear the teeth out on your gears. So after a while, after doing this enough times, guess what? Your whole machine is falling apart. So it shouldn't be any surprise when you have a machine that's been through this kind of stuff. Try not to do this to a new machine, because even though it's tighter and it'll handle it better, you're wearing it out. And when that machine is 20 years old or older than that, the thing isn't going to be worth anything. You know, yeah, the spindle will run, and you'll be able to poke some holes, but generally speaking, it's not going to work so well. This here causes what I call catastrophic tool failure. That is where you've broken the edge so badly, or possibly busted the drill right off, that the thing won't cut anymore. And that's what I like to call a catastrophic tool failure. That is actually a dangerous scenario from the standpoint of the machinist doing the work, and even as a person just standing around. Because if that drill breaks with that how it's heat treated, that could actually send shards of heat treated steel flying in different directions. It could. I'm not saying it would. It depends on a lot of other circumstances, but it's not a good practice, and it's not a good situation to be in. Thank you for your time. God bless.